Experiences are what people love the most about travel. Viator is a website and app where you can book travel experiences like hiking Mount Kilimanjaro in Tanzania or enjoying the views while cruising on a catamaran in the Caribbean. They offer everything from simple tours to extreme adventures. With over 300,000 bookable experiences in 190 countries, there's something for everyone. Plus, Viator's travel experiences have millions of real traveler reviews, so you have the information you need to book the best activities for your trip. When you book a travel experience with Viator, there's always flexibility and support with free cancellation, payment options, and 24/7 service. Download the Viator app now and use code Viator10. That's Viator 10 for 10% off your first booking in the app. One app, over 300,000 travel experiences you'll remember. Do more with Viator.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again. Thank you for joining us on this, the Space Nuts podcast. I'm your host, Andrew Dunkley, and joining me every week without fail, whether he likes it or not, is astronomer at large, Fred Watson. Hello, Fred.
Yeah, sometimes I'm only here in voice, the rest of me's somewhere else.
It can be a bit like that. That's life as we know it.
It is life, that's right, yeah.
Ask me what I've been doing for the last week or two.
Andrew, what on earth have you been doing for the last couple of weeks?
I've been travelling, surprisingly. We've had episodes every week, and people would think, he didn't go anywhere. But we did a bit of a cram a couple of weeks ago, just to keep the show going. And
things we do.
I did a little trip with Judy to a place that is well known to Australians and New Zealanders and people in the Southwest Pacific called Papua New Guinea. Which is not probably on many bucket lists, I wouldn't think, because I think people have a preconceived idea of New Guinea, and I would say to a certain degree they are right. It is a very, given the way we live in the Western world, it is a very primitive place in many respects. We took a cruise ship out of Brisbane. Took 2 days to get to a place called Alatau, which is part of Milne Bay province. Now, Australians would probably be very much aware of Milne Bay because it was the site in June of 1942 of a major battle between Japanese soldiers who invaded Milne Bay to try and take airstrips from the Australians. And had they won that battle, the Japanese would have been able to supply the troops on Kokoda, which would have ultimately led to victory there. They would have taken Port Moresby probably, and that would have opened up Australia to a Japanese attack. Thankfully, the Japanese made two mistakes. They underestimated our forces and only sent 1,000 men to fight against 9,000 men, and they landed in the wrong place. And that was the recipe for failure, and it was their first defeat on land in the Pacific campaign. And I got to walk the areas where the battle was fought. There was a VC won there by a 19-year-old Australian who basically single-handedly fought back a Japanese attack, paid with his life. And, it was just mind-blowing, just seeing the layout of it and where it all happened. It was close quarters fighting for 4 days. But, one of the great victories of the Second World War in the Pacific. And then we went to a place called Kirrawheena, Fred. Kirrawheena is a little island which hasn't changed much over all the time people have lived there. They don't have electricity. They only have two water sources, one of them being a cave. Wow. And they basically live off the land. They grow yams and they fish. And we hired a local to take us on a bit of a walking tour of her village. And they live the way you would see in the movies. They live in grass huts that are built off the ground. They build little fires to cook. Very, very basic living. And as she said to us, you either work or you go hungry. And that's their life. And she was in her 30s, we estimated. She has 4 children. And she has never once in her life stepped foot off that island, which It just blows my mind. And they do rely on the cruise ship trade. That said, they use the local New Guinea currency, which is kina, but the island people actually use banana leaves as a currency, which just blows your mind. And then we went to a place called Conflict Island, which was an uninhabited island, but it was bought by the lease was bought unseen by an Englishman, an English aristocrat who was a close friend of Prince Charles, I'm told. He was on the island while we were there, and they've just turned it into a bit of a tourist hub, and it is what you would call picture perfect. If you were to look at a postcard of the South Pacific, that's what you would see. So it was quite the opposite to Kirawina in terms of what they were offering. But he's turned an island of no people into a little community. He employs 74 people who live on the island full time just to create a tourist destination. So he's done good things for the local economy. But fascinating trip, fascinating people, just really opens your mind as to how well off we are in the first world. And you just see how people live in places like that, and you think, you know, what are we doing on this planet that creates such a massive divide between rich and poor?
Yes, exactly.
But and of course we're spending all the money on astronomy. That's what we're doing. Now,
yeah, about $23.50 of it. That's
pretty much.
Yeah, no, I take your point there. I often wonder what we did to become so privileged here. Yes, there are many people throughout the world who don't have the things that we've got, and it makes me very sad. Yeah, makes me sad.
You know, people are doing it tough in first world countries as well. Certainly not brushing that under the rug, but. When you see how these people, like, they go out in a canoe every morning to fish. Yep. And I saw them bringing in tuna, just little ones, baby tuna, and they were bringing them in by the dozens, and that was for them to sell and eat. That's their life. And others grow yams and they harvest, and it's a big deal to them. And I'm glad I did it. I'm glad we went. I think it's important to learn this kind of stuff and make a better fist of ourselves in terms of being more human, if I can put it that way.
Exactly.
Now, that's got nothing to do with astronomy. Maybe the early navigators used astronomy to get there. But today we're going to talk about some more fast radio bursts, which have got people scratching their heads. These ones are very regular. They come and go in bursts over 4 days, and then then disappear for 12 days, and then they're back again. And it's got people wondering if they're from an extraterrestrial source or if they're natural. I'm going with the latter. And a possible explanation for dark matter using Newtonian dynamics, whatever that is, and questions about pulsar, GPS and space junk today. So that's what's on the agenda in this edition of Space Nuts. Fred, let's start with these fast radio bursts. And astronomers have been fascinated by these radio signals that have been bombarding us. And this burst, in particular, this group of bursts, is happening on a basis that would suggest, well, gosh, they're so regular and so sort of specifically timed, they can't be natural. But then again, they probably are.
You can bet your life they are, Andrew. But it has got people excited. So what's the story with fast radio bursts? You and I have spoken about them many times before. They turned up, first of all, in archival data from the Parkes Radio Telescope here in Australia. Back in 2007, people were looking through the archive and found these intense pulses of radio radiation that seemed to come from all over the sky. The intensity is such that if you imagine the kind of energy that would have gone into a pulse like that, it's the kind of energy that the sun would deliver in 1,000 years or 10,000 years, and yet we're getting it within a millisecond, a thousandth of a second. Yeah. So very high energy events, very intriguing because for a while they just appeared as single out of the blue events, which made it very difficult to track down where they were coming from, because you'd record one of these things with a radio telescope, but not be able to home in on exactly where the source of it was, because basically the telescope wasn't set up for that. Then I think in 2015 or thereabouts, if I remember rightly, it was discovered that at least one of these things didn't just burst once, it actually repeated. And that was the first of the so-called repeating FRBs. It was discovered in archival data actually from the Arecibo telescope in Puerto Rico. And it was found that this thing actually pulsed, not in a regular fashion, but not just once, but many times. Since then, a whole host of these things have been turned up, and a particularly successful instrument in finding them has been something called the Canadian Hydrogen Intensity Mapping Experiment, which is known as CHIME. That's the acronym. It's in British Columbia in Canada, and over I think the past year or so, CHIME has actually detected something in the region of 20 of these repeating fast radio bursts. Now, the great thing about the repeaters is because they come from, the same area of space, and that means that you can kind of home in on them and get a much more accurate idea of where the source is in terms of its direction in space. And once you've got that, then you can follow up with an optical telescope, a visible light telescope, to actually look at where these things are coming from, where the radio signals are coming from. And that's happened now for a number of fast radio bursts, the repeaters in particular, and they seem to come from pretty nondescript regions of pretty nondescript galaxies. A fairly modest galaxy will have a fast radio burst seem to come from its outskirts, from the outer spiral arms, rather than being concentrated at the centers of these galaxies where we know the action is taking place, because in most galaxies we believe there's a supermassive black hole lurking in the center. And if you've got activity around that stuff being swallowed up, then that might be the kind of environment you'd expect to find high intensity radio signals coming from. But it's not. It's in, relatively rarefied regions of the outer galaxies. So that's the story so far. One radio burst in particular now has people intrigued, because not only has it been found to sit in the outskirts of a fairly normal galaxy, about 500 million light years away. As you've just said, a paper that came out within the past few days has demonstrated that it's actually got a kind of cyclic, a periodic repeating structure to it. So it's not just random repeats as the others seem to be, but this thing has a 16.35 day cycle. And what happens is in that cycle, you get 1 to 2 bursts per hour over a 4-day period. So that's lots of bursts. And then you get 12 days of nothing. And then it all starts over again.
That is a bit strange.
It's very intriguing.
So it might suggest that it's coming from something that's rotating away for a portion of time, and then
something like that. That's right. So one of the scientists who's involved with this study has said, and I think this probably comes from their press release, the discovery of a 16.35 day periodicity in a repeating FRB source is an important clue to the nature of this object. One possibility is that it's an object orbiting a star which sends signals out only at a certain period of its orbit, or it could be a signal sent by a binary star system where you've got a massive normal star and a highly magnetized neutron star, something we usually call a magnetar. So it could be something where the signal's only visible at a certain time in the orbit of one of these things, or it could just be a single object. And what we see could be caused by rotation or a kind of wobbling of the axis of this star. So these are all possibilities. The paper in question that produces these results has got, I didn't count the authors, but it must be in the region of 60 authors. Wow. It's called Periodic Activity from a Fast Radio Burst Source. It was released on the 3rd of February and gives the details of this object. This 4-day window when you get lots of bursts, then there's 12 days of silence. And then, the whole thing repeats every 16.35 plus or minus 0.18 days. So it's remarkable. Is it due to aliens? No, probably not.
Probably not, as much as we'd love that to be the case.
We would. There is one, you and I have talked about this before, Avi Loeb, who's the director of the Harvard-Smithsonian Institute for Astrophysics, Center for Astrophysics. He wrote a paper some years ago speculating that fast radio bursts were the result of high-energy beams radiated to light sails to propel alien spacecraft around their respective galaxies. I don't think anybody believes that, but I don't think his paper's been disproved either. So, there's no conclusive evidence that says, no, this cannot possibly be that. He worded his paper very carefully. He said that the parameters all fitted what you might expect from a light sail. But I don't think that will turn out to be what it is. And this periodicity is definitely a clue in trying to understand these things better. So, as always with these things, Andrew, watch this space. We might have more to say not too far down the track.
Including its name, which I'm going to ask you to furnish us with.
Well, it's usually abbreviated to FRB 180916J0158 plus 65.
There it is.
That's not quite its full name. Actually, we'd normally just call it FRB 180916 because these things are named after the date at which they first burst, the first burst. And that was on 2018, September the 16th.
Indeed. All right. Hopefully more to learn. One of the great mysteries of the universe that's still to be resolved. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson. Let's take a break from the show and hear a word or two from our sponsor, Grammarly. Now, I have to say I'm a big fan of Grammarly because I've been using it for a few years now. Very helpful for authors, but also really good for everyday life. They've saved me on a few occasions, particularly with spelling, but also with a few issues that didn't quite make sense. It's built by linguists and language lovers, and Grammarly's writing app finds and corrects hundreds of complex writing errors, so you don't have to do it yourself. Word by word, day by day. You can easily copy and paste any English text into Grammarly's online text editor, or just install Grammarly's free browser extension for Chrome, Safari, Firefox, and quite a few others. Grammarly's algorithms flag potential issues in the text and suggest context-specific corrections for grammar, spelling, and vocabulary. Grammarly explains the reasoning behind each correction so you can make an informed decision about whether and how to correct an issue. Grammarly helps you write mistake-free Gmail, Facebook, Twitter, LinkedIn, and nearly anything else you write on the web. For you, the listener of Space Nuts, Grammarly is offering a free download of the Grammarly software. So if you'd like to download Grammarly today, go to getgrammarly.com/spacenuts. Again, that's getgrammarly.com/spacenuts to download Grammarly for free and let them know you came from us. I'll include the link in the show notes as well. And now, back to Space Nuts.
3, 2, 1.
Space Nuts.
Now, Fred, I think last episode I said to you that sometime in the next week we were going to crack the 1,000 when it came to YouTube subscribers. Well, guess what?
We didn't.
Yeah, we did.
Oh, did we? Wow.
We did.
I thought you were going to say we got to 998.
Well, it's funny you should say that because somebody messaged me to say I'm 998.
Oh, good. There you are.
No, I'm not kidding. That really happened.
Yeah.
But I don't know who was 1,000 because now it's 1,004.
Well, there you go. Well done, everybody. You YouTube people. Thank you very much.
What does this all mean, Fred?
I have no idea. None whatsoever.
No, I was just told get it to 1,000, so I've done that.
Right.
But what
we get a Nobel Prize now, don't we? Isn't that what it is?
So. But yeah, keep going. If you're a YouTuber and you haven't subscribed to the Space Nuts YouTube channel, it's at youtube.com/C for Charlie/Space Nuts. And you can listen to every episode there by pressing one button, and they'll just keep on playing ad infinitum. Never, ever ending.
Can you imagine anything worse?
Getting my teeth pulled without an anaesthetic would probably only be slightly worse.
Yeah, slightly worse. Yeah. Okay.
Yes. Now, our next topic, Fred, is an interesting one as well. This involves dark matter and the work that's going into trying to figure out what it might be. And in this case, they've used Newtonian dynamics to come up with a potential explanation, but I see you shaking your head. You don't seem all that convinced. Or maybe I just didn't explain it well enough.
Well, okay. So when dark matter first was postulated back let me just qualify that in the modern era, if I can put it that way, because back in 1933, Fritz Zwicky realized that there was something going on that we didn't understand. And he actually is the person who coined the term dark matter. But it wasn't until 1978 when Vera Rubin, great American astronomer, wrote some papers that the world started taking notice of the idea that without this stuff, galaxies could not rotate, they would fly apart because there's not enough material in them to hold them together. And that's the beginning of the modern era of dark matter studies. Now, in the wake of that, the first thing that people said almost was, okay, maybe we've got gravity wrong. Maybe it's not that there's something there that we can't see, some dark matter. Maybe we've got the idea of gravity wrong. And very quickly, a scientist called Mordechai Milgrom, who's in Israel, I think he's Tel Aviv, I might be wrong there, but he's certainly in one of the Israeli universities. Milgrom postulated the idea that our knowledge of the way gravity works and that, well, you know, we've got two theories of gravity. One is Newton's, one is Einstein's. They effectively give you the same answers unless you're in very high gravitational fields, in which case Newton's theory breaks down. But Newton's dynamics and Newton's gravity theory is good enough for a lot of what we do, what we understand when it comes to the rotation of galaxies and things like that, because you're not talking about very high gravitational fields. So what happened was Dr. Milgrom, Professor Milgrom, in fact, he produced a theory which is usually called MOND, and MOND is just an abbreviation for Modified Newtonian Dynamics. And what it means, what it says is that the laws that Newton set down work really well under what you might call normal accelerations, normal experiences of gravity, like what we have here on Earth, like what we've got in most of the solar system. But the suggestion is that when those accelerations get very, very weak, then it breaks down. Then Newton's law doesn't work. And the suggestion is that under very low accelerations, like what you get, you know, in the outskirts of galaxies, the forces that hold galaxies together, maybe the dynamical force becomes stronger, which is why galaxies might hold together under these weak accelerations. So Milgrom produced this theory. It was analyzed very closely in the early 1980s and eventually was not exactly discarded, but was shelved, because if you put MOND into your big picture, like the way clusters of galaxies behave, it doesn't work. It works for single galaxies, but with clusters of galaxies, and more especially with the way we think the universe behaved in its very early period, it doesn't work. And that's why people have gone off on this wild hunt for the last 30 odd years looking for dark matter, which we haven't yet found. We ruled out things like orphan planets and black holes and dead stars very early on in the piece. And now the thinking is that what we're dealing with is a subatomic particle, or a class of subatomic particles that don't interact with normal matter except through gravity. And that's very much the accepted picture, with a fair bit of supporting evidence. However, there are still a few scientists, and actually I know one of them who's embarking on a PhD on exactly this topic. In fact, I think he's actually a Space Nuts listener, so you know who you are.
Okay.
Peter, and so it's basically something that people are looking at again. That's the bottom line. That because we've not found what the sort of natural physical ideas, because we haven't found what that's telling us, namely this species of subatomic particle, then you've got to look at other possibilities. So that's the backstory, Andrew. Sorry, it's taken rather long.
No, that's okay. We need to sort of get ourselves in the right position to move forward.
Yeah. So the front story now is that a group of scientists, led, I think, by Dr. Pavel Krupa, who's at the Helmholtz Institute for Radiation and Nuclear Physics at the University of Bonn, and also at the Charles University in Prague, this team have essentially said, okay, let's see what happens if we do have MOND and you've got galaxies forming in an early universe. And so what they've done is run these gigantic simulations. Now, these are not uncommon. They're always done on supercomputers. I know of a few people or a few institutions throughout the world that have done this kind of thing, one most very notably in the University of Durham in northern England, where you basically start off with what you think are the laws of physics and what you think is the material that's in the aftermath of the Big Bang. And then you run it all under the influence of gravity, and lo and behold, what you get is galaxies. But the thinking has been that without dark matter, you wouldn't really get galaxies that look like the ones we have today. And the new work, which Dr. Krupa and his colleagues have put together, actually disproves that, because what they've done is they've built a universe in the computer in which MOND works, modified Newtonian dynamics, and then in the aftermath of the Big Bang, you start off with these clouds of hydrogen, you press the button and away it goes, and what do you get? Well, you get galaxies. You get something very, very similar to what we see, stars and galaxies, emanating within the first few 100 million years of the Big Bang. One of the comments that has been made on this paper is really interesting. It comes from basically, actually, it's I think it might be from the press release that they issued. The paper, by the way, if anybody wants to look it up, is called "The Formation of Exponential Disk Galaxies in MOND" by a whole succession of authors, 5th of February, Astrophysical Journal. But the comment that's been made is calculations based on the existence of dark matter are very sensitive to changes in certain parameters, such as the frequency of supernovae, exploding stars, and their effect on the distribution of matter in galaxies. And we know that. We believe supernovae actually drive really quite a lot of the ingredients of galaxy formation, stars exploding at the ends of their particularly short lives. Yeah. But what they say is that in the MOND simulation, these factors hardly played a role. So that's really quite interesting, that MOND actually, looks a little bit more stable in these simulations than the dark matter models. However, they do make the point that the simulation is only a first step, They've really made very simple assumptions about the distribution of matter in the young universe. And what Professor Krupa says is we now have to repeat the calculations and include more complex influencing factors. And then we will see if the Mond theory actually explains reality. So what they're saying is that this work is really just a starting point, and that they want to put in some more parameters that perhaps more closely match conditions in the infant universe and see whether we still get galaxies like the ones that have been produced by this simulation. It's really interesting stuff, and I kind of applaud it in a way, because even though Mond does not look like the answer to the problem of dark matter, it's still worth exploring to see what you come out with at the end of it.
Yeah, it's such a difficult thing to study because the unknowns are so significant. Where do you start? You've got to try something. So they've come up with a concept that they're working with to see if it could work, and then they can build on the successes and or failures of it to recalibrate the concept again, I suppose.
That's right. That's exactly what it is. You could almost call it trial and error, but you're putting in, it's not completely random. You're actually putting in starting conditions which basically bear as much resemblance as you can muster to what you thought the conditions would have been at that time. And, we've got other sources to look at that. We know, for example, a lot about the flash of the Big Bang because we can still see it in microwave radiation. So all that information factors into it as well to see what you get.
Indeed. I was going to say, are we not thinking big enough with solving this dark matter thing? But I suppose if you're trying to replicate what happened straight after the Big Bang, it doesn't get much bigger than that.
No, that's right. What else do you throw in? Magic, perhaps. That would
magic is the reason.
That would do it.
That's got to be the explanation.
Yeah, maybe. Yeah.
All right.
Hopefully, science will produce the answer. One day, you and I will laugh at these conversations, Andrew, because we'll know exactly what dark matter is, and that'll have solved the problem.
And then we'll look back at all our episodes where we talked about it and gone, well, we weren't even close.
No, not even close. That's right.
We were adequate, but not close. There it is. You're listening to Space Nuts with Andrew Dunkley and Professor Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
And a big hello to our patrons who've been supporting Space Nuts for a good while now. And of course, if you are a patron, there is bonus material available at patreon.com/Space Nuts. We're adding to it every week, or almost every week, on a regular basis. So if you're a patron and you have a question for us, indeed, send it into us via our website at bytes.com/Space Nuts, and we will endeavour to answer the question on our patrons page, patreon.com/Space Nuts. If you would like to become a patron, you can go to the same site and learn all about it. Maybe it's not for you, but maybe it's something you'd like to do and contribute to the program in whatever form you deem fit. And we appreciate the support, of course. And speaking of questions, Fred, we've got a couple of audience questions to try and bump off today. The first one comes from David Findlay. Hi, David. Hi, guys. He says, I've seen it mentioned before that pulsars can be used for navigation in deep space. Do you think it might be practical in the future to have a pocket universal positioning system that could tell your location anywhere in space? He also says, are pulsars radio loud enough to do it without a large antenna? Interesting, David.
It's a great question, Andrew, and that's absolutely right, that you could use pulsars for navigation, and that's because pulsars are incredibly regular. They are better than most atomic clocks in keeping perfect time. So that's the key, of course, to GPS, the Global Positioning System. It's the time signals that you get from the satellites that you can see that actually give you the triangulation to get your position on the Earth's surface. So from GPS to UPS, Universal Positioning System, although I think that those initials have been used somewhere before, but the UPS that David's suggesting, it's certainly true that if you know of enough pulsars, and you can kind of see them all with your radio telescope, then you could pinpoint your location. The problem is the radio telescope bit. So the second part of David's question, are pulsars radio loud enough to do it without a large antenna? Not at the moment. The technology that we have at the moment needs things the size of the Parkes dish, which has a 64-meter antenna, very big. It's not the kind of thing that you can fold up and put in your smartphone.
Definitely.
However, remembering what mobile phones were like 30 years ago, where you nearly needed a big antenna to make it work, maybe one day we'll have such sensitive radio receivers that we could have pulsars in our pockets so that wherever we are in the universe, we would know. Then you have to ask the question, well, why would you bother doing this? Because the kind of distances that you would need to travel to make any difference to which bit of, which set of pulsars you were seeing, that is well beyond what we physically can do with our present technology. So, yes, it's a rhetorical question. Could you do that? Could you have this kind of navigating system? And rhetorically, the answer is yes. But it's probably not something that we're going to see anytime soon or need anytime soon.
Yeah, well, I suppose the latter is the issue. But if we reach a point in our history or our future where we can travel vast distances reasonably easily, it would have to come into play then.
It would help. Yeah, it would be very helpful to have your pulsars, but you'd have all kinds of weird and wonderful relativistic effects to take into account as well when you're doing that. It would be great stuff. And you never know, that kind of navigation might give us insights into dark matter. Who knows?
Oh, here we go again.
Yeah.
You never know. All right.
Yeah, you never know.
Thank you, David. Hopefully we gave you a bit more to think about there. And thanks for the question. Let's move on to Sean Farrell's question. Hello, Andrew and Professor Watson. Oh, he's being very diplomatic, isn't he?
No, it's very formal. I do.
Hello, Sean. Now, the ESA launched a 100 million euro satellite with a grappling arm to grab onto a large piece of space junk to change its course for a re-entry and burn up in the atmosphere as a test on removing space junk. I would like to know if a CubeSat could, let's say, stick itself to space junk and fire a small booster or rocket to do the same as ESA's 100 million euro plus project. Utilising CubeSats may be helpful and less costly with certain debris. Send up a swarm of CubeSats to work together and guided by the ESA control. Interesting thought. He also goes on to say one of Russia's top-of-the-line spy satellites just broke apart. It was alleged that the space debris may have hit the satellite and now more space junk. Maybe you, me and the professor should patent the CubeSat idea and get rich. I enjoy the show very much, and you guys are great together. Well, we're miles and miles apart, but I think I know what you mean. I suppose we probably would be great together. We would, indeed.
We're in the same room.
Yes. Now, let's talk about the grappling arm and the potential for CubeSats to do the job. What do you think of that idea?
Yes, it's. I think actually people are looking at exactly this. The problem of space junk is increasingly recognised as something that needs to be faced up to and needs to be tackled. And that European Space Agency project that Sean refers to is just one of a number of trials to look at the kinds of technologies that might be usable to bring satellites down.
Well, I think they've already tested a harpoon, have they not?
Yeah, that's right. There's a number of these experiments that have actually been trialled, and that was just one of them. The grappling arm was one. There's one with a net as well.
That's right. Yeah, I forgot about the net.
Enfolded around space debris. So I guess what you're trying to do here is to try out technologies that might be used on a kind of production line to bring things down. But you can bet your life that when they do put these into action, in reality, it will be with things not much more expensive than CubeSats, which of course are a factor of 100 less than $100 million. The CubeSats are in the region of $1 million to $10 million. To build.
You could build 100 of them, or 200 of
right.
them, actually, if you convert the euro to Australian dollars.
Yeah, indeed, and that's that is probably the way ahead for this kind of technology. The big issue is exactly what do you use to do the job of deorbiting your piece of space junk, and a CubeSat equipped with a rocket might actually not be big enough. If you're trying to stick it to a 10-ton spacecraft that's gone AWOL and you're trying to deorbit it, it might just not have the amount of space needed to put in a large enough booster or a large enough rocket. And I think what might be a more promising technology is to erect, maybe inflate a large, effectively a sail, something with a very large area in space that will, act as a brake on the object that you're trying to slow down by virtue of the fact that it's got atmospheric drag, that the residual atmosphere up there on something with a big enough area will make its orbit decay. That, of course, it depends on what orbit the space junk is in to start with, and that's only going to work for what we call low Earth orbit, which is of order a few hundred kilometers, up to about 1,000 kilometers. So I think the possibilities are extremely, there are many of them, and many institutions are looking at these possibilities. But you can bet your life that CubeSats will play a part in this when we start to see this being done for real. Another thing that's being explored here in Australia is the use of lasers to nudge things into different orbits. There's an organisation called SERC, the Space Environment Research Council, I think it is. Research Cooperation. It's a cooperative venture. They are looking at the idea of using lasers to nudge things into orbits that will bring them down. All of these things come, of course, with an interesting legal aspect, because if you've got a spacecraft which you bring down and the people who operate it don't want that to happen, well, that's a hostile act. And suddenly you're in very different territory. And it's something
piracy.
It could be piracy. And I don't think this has really been properly ironed out yet. I don't think the details have been legislated anywhere. So we're still facing really interesting issues there.
Indeed. But, Sean, if you want to go ahead and put that patent in our names, I'd be more than thrilled to be involved.
As long as we don't have to pay anything.
No. Got no money. But I love your idea. And thank you for your question, Sean. Greatly appreciated. Very thought-provoking indeed. Now, Fred, before we finish, I happened to be at Sydney Airport the other day browsing through the science section of a bookshop, and I came across a little book called Cosmic Chronicles. There you were on the bookshelf. Now, I should point out you were on the bottom of the bookshelf and only the spines were showing. I think you need to slip your promoter a few more dollars.
The problem is when your surname starts with W. They always put these in alphabetical order of author. Yeah. So I'm always at the bottom.
I know.
But
that's not fair. You should be, your title starts with C.
Astronomer at large. That's right.
Well,
I'll be at the top.
Title, indeed.
What cheered me about, because you sent me a little snapshot of what you saw, which I thought was great. Thank you very much for that.
That's all right.
But what cheered me was that there were only 2 copies there.
Yes.
And almost certainly ordered 10, and that means they've got rid of 8 already.
Or there wasn't enough room on the bookshelf and they're underneath the counter.
That could be right as well. Yeah.
No, I hope they've sold. I hope they have. Of course, if you want to buy your own copy of Cosmic Chronicles, which is what it's called everywhere except America, I believe.
No, it's actually called... It's called Cosmic Chronicles nowhere except in Australia.
Exactly. So everywhere else it's called...
Exploding Stars and Invisible Planets.
That's hard to remember.
Yeah, I know.
But there's a Space Nuts bookshelf on our Space Nuts website, bitesz.com, bitesz.com/Space Nuts. You can listen to our podcast via that website, but you can also go to the Space Nuts bookshelf and pick up a copy of Fred's book. And he's got more than one. He's published 1.5 so far, I think it is. Probably a few more. But, yeah, it was good to see it there. I was chuffed. I was.
Thank you.
That's where we've got to wrap things up, Fred. Thank you so much.
Thank you for having me, Andrew.
I'm glad you could make it. It would have been very hard to talk for this long by myself. No, it wouldn't have. I wouldn't have talked much sense, but I could have talked for this long by myself.
Yeah, that's all right. It would have been equally entertaining. But thank you very much for having me, and we'll speak again sometime soon.
Indeed, we will. Professor Fred Watson, astronomer at large, one half of the not-so-dynamic duo that makes up Space Nuts. And thank you for your attention and, of course, your contribution to the program. And we'll catch you again next week on another edition of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at bitesz.com.
This has been another quality podcast production from bitesz.com.